My name is Lisbeth and I'm Program Manager at Wageningen University and Research, and I'm very pleased to moderate this session today. We are seeing major developments in textile policy, particularly with the upcoming digital product passport under the eco-design framework. And at the same time, textile sorting and recycling systems are rapidly evolving, becoming more data-driven, more automated and more interconnected. Today's session explores therefore the intersection of these developments. So how can digitalization and specifically the DPP support and improve textile waste sorting? But before we begin, a few housekeeping points. Please keep your microphones muted to ensure good sound quality. You can use the chat function to pose questions at any time during the presentations. And we will address as many questions as possible during the panel discussion at the end. The session is being recorded and the recording will be shared afterwards with you. And if you experience any technical issues, please let us know also via the chat. So, well, let's get started. Our first speaker is Emma Ennebok, Project Manager at RISE. And Emma will present a practical checklist to help actors in the textile industry prepare for digitalization and DPP requirements. So Emma, please go ahead.
Thank you. I can just shortly guide you through the agenda. I will introduce and then go through the practical checklist and hand over to my colleague that will speak a bit about digitalization and how relevant data can support and improve textile sorting. And then we will have a couple of fantastic pilot presentations from CISUTAC, but also from Texaid and also from Atelier Reforma, and then last a panel discussion. So we will have a great morning together, I hope. So I will start a little bit to talk a little bit how digitalization can be a key enabler for circular textile value chains. Just a short reminder of something that is perhaps a fact that we all know, but an important one in this context. Global textile circularity is only 0.3%. This is highlighting how urgently the industry must keep products in use longer, but also shift from using virgin inputs to scaling secondary raw materials. And why do we need the digitalization to improve textile waste sorting? Well, of course, a waste becomes a resource only when we can identify it. So identifying waste is a key. And digitalization has a potential to make that identification fast, accurate, and scalable. So that is why digitalization is important here. So one example is that by enabling more accurate identification of materials, especially the fiber types required for high quality material recycling, digital tools can help overcome limitations of manual sorting. But also, of course, it can help us to process far larger volumes of textile waste faster and more cost effectively, hopefully than in the future when scaling these systems. So data can help us bridge many of today's gaps and creates a foundation needed to scale more circular textile solutions. So here are a couple of examples of where data is accessible and reliable. When data is accessible and reliable, it is then essential for improving some circularity work. So for example, it can help us with quality control, it can help us with decision support, it can help us with classification of materials, for examples, as a couple of examples. And I'm sure that you are all aware of the upcoming legislation of the Eco Design Directive. And in the near future, it will come the digital product passport as a part of the Eco Design Directive. And here products will be required to provide easily accessible and need-to-know information through a digital product passport. And while the exact requirements are not yet finalized, they may include details such as origin, materials, manufacturing processes, or climate impact. And the list that you can see here on the slide are the performance information requirement categories that are defined in the Article 5 of the Eco Design for Sustainable Product Regulation. So this is what we know now, and as you know, the process is ongoing. And here is the indicative timeline for it. So yes, when is the near future and when we know more? Here below us, you can see the timeline for the process leading to the adaptation of the ESPR and the development of the product-specific requirements and the adaptation of the Commission, and then further than their transportation into the member states. So roughly 28, 29, we will see this in practice, a digital product passport with product-specific requirements and more information accessible, and then hopefully this can drive then more scaling of circular solutions. So this is ongoing, and we have then a couple of years to prepare for this shift, but also, of course, start other solutions that not only focus on the digital product passport. So this is why in the CISUTAC project, we wanted to do a practical checklist for preparation for the textile industry. We do not know everything right now today, but we know enough to start the preparation. So this on why we did this is also because we got some insights in our previous work that the industry still has challenges with data management. And a couple of examples of these challenges are that companies still handles a lot of their data manually in spreadsheets. And integration of digitalization is still going slow. A majority of the companies that we talk to in a survey, they don't have mature tracking system yet for product data in their supply chain. A lot of the companies that we had in our survey still relied on statistical average and focused on the primary fabrics and not on the full product composition. And terminology and categorization remains inconsistent across companies. So basically the same things could be called different things, different wordings or different terminologies. And only a few of the companies that we had in our survey could extract detailed monomaterials data, which is essential for fiber-to-fiber recycle. So these are a couple of examples of the data management challenge that we found in our survey that we did in the CISUTAC project. So based on this, but also work that we're going to talk about today in the next step, where I hand over to my colleague Catherine, we then did a practical checklist where the target group is mainly producing companies in the textile industry. So here we present 7 steps where you can start with exploring what is the relevant data, and also how you can start with the journey towards a more digitalized management of data throughout your value chain in order to be better prepared for the upcoming digital product passport, but also, of course, to scale circular solutions for reuse, repair, and recycling. So this checklist can be found on CISUTAC webpage, but also on the CISUTAC LinkedIn, and it's an easy readable PDF on a couple of pages, so it's easy accessible for you to absorb. So we hope this can be used and or shared further. So now we will go into a little bit more of the topic of today, and I will hand over to my colleague Catherine.
Okay, then let's continue with the slides. Hold on. So you see, okay then. Yes, so we have had the possibilities to work with a great consortium in the CISUTAC project, and it's a very broad consortium from the industry, and on a very early stage we looked into interviews and discussed with the different stakeholders what would be the most relevant data needed to sort textiles. And we also very early wanted to create a tool for decisions for the sorting industry. And we also based it on that we will have more data from the digital product passport. So there was a lot of assumptions, and also important to follow what was going on with the work within, for example, CIRPAS. So we created a tool, which you can see here on the CISUTAC webpage. The first version was released 2024. And here you can look into different options how to click in and get an idea on how a supporting tool could work. Not everything is possible to choose right now. We will have a new version during this year, where we also have used conclusions from the pilot that you will hear more about later on. And here you can also see that you can get options on for reuse, repair, and different recycling methods. And then at the bottom of the page, you can download the Excel, where it's a first version on how different data points could be relevant for sorting. And also, meanwhile we worked on this, we can see there's been an increase on technology development as well for recycling, for example. So different data points that we got in the beginning was very relevant at that stage, but also could be less relevant on a later stage, depending on what blends and what type of challenges you have for different types of recycling. And we also got more insights and learnings around reuse and repair. So therefore we need to update it. And the tool will also be able to you will be able to download it later on. As well, to mention again, we have had focus on, in the CISUTAC project, is cotton, polyester, polycotton, and elastane, and also focused on the main material textile waste streams, more to say, in the EU, looking into what are the most common blends, most common type of products, and then we try to create a sort of a base on that could be easy to change afterwards. So it's a first way of looking into a type of flexible tool, we hope, in the end. So as Emma mentioned, the data is very crucial to move forward, and that's why we also looked into what data do you really need behind the textiles to take the steps forward. We ended up with 23 data points for the decision routes, and that's where we started. And we have looked into different ways on handle this and what can you actually access and what is most likely to be a part of the digital product passport. Very high up on the list came, of course, fiber compositions, and then also different textile finishing, chemical content, and other content in the textile product. And also, of course, as you see on the top left corner, I think it will be for you, is the condition level, and it's very crucial to understand and how to evaluate the product and where it should go for sorting. The next step was to look into data points that is crucial for recycling. and what inputs do you need for that, and how could the recycling industry scale up, and what more data would they like to have to take the next steps. And of course, again, if it goes for recycling, it needs to be quite poor level of the textile. So we're very much looking into if it goes for reuse and repair first, and then for recycling. And then we added on data points that would be really fantastic to get from the digital product passport, more accurate data from around the fiber composition, and also around textile finishing, chemical content, and it also in the end recycled content, and also product construction and so forth. So there's a lot of interesting data you could read more around. But 10 of these we set as a major part. This could actually make the industry take a little bit leap forward. And then also looking into repair and reuse. And here we found out 9 valuable data points that could also help out. There's a lot of knowledge already in this industry, and also how to evaluate textiles and understanding of what it could be used for, and what market it is, and what kind of business models. Also this you will hear more about later on. But what could a digital product passport add on, and what data could be needed? So here we also found out things around brands, price, product type, and so on. Now it's an echo because someone has not muted themselves, but I hope that will work now. And then we also looked into technology, what technology would be needed and what technology we have today. We know there's a lot of things going on right now, both within sorting technologies, the industry that is there already. They're also working more to find out new solutions, but also it could be AI, for example, that you will also hear a little bit more about later on. But we looked into what is accessible today. And here we see clearly that new technology is very good to use still, and it also very efficient for sorting. But also it needs to be a combination of different technologies. And from the data points, we found that color and fiber composition, and also at some parts also disruptor could be detected. But it's quite a little level to find out for the technology around sorting. And then one data point is still, in the end, always sort of coming up again within the pilot, but also in our work, is the condition level. And that is nothing you can read from the digital product passport, of course. It's really how do you evaluate your product or the textile that's coming in from textile waste. And that this is also something we worked further on in the CISUTAC project. So let's say now this jacket is very new, but let's say if it's a worn out condition level, and then you have really nice raw materials that you could actually use at some point. So if it's decided that it should go for recycling, you can access different data points to guide it if it should go for chemical or mechanical recycling, for example. And when going back to the condition levels, we set a suggestion of 5 levels from very low to premium, and then also a description on how that could be used. It could also be a standardization in the end for the industry as a starting point to say the same things in the industry, and also to get a better understanding. Let's say if you go into this industry and you want to use some tools, you could start on some point looking into on how to describe those levels. So for very low level and low, it should go for either incineration or recycling. Medium is quite critical because depending on brand and what type of defects it is, but mainly should go for repair or for reuse. But at some point, depending on brand, could also go for recycling, or it could be a low level and it's a very high-end brand and a vintage product, and it could be, for example, acceptable with some kind of defaults, and then it could go for reuse. So it's a little bit tricky with these levels, and we're still working on it, and this is also something you will hear about later. And some key insights from this around reuse, repair and recycling is really how crucial it is to evaluate condition level of a textile product. The knowledge and skills and expertise that's in the sorting industry is very high, and how can you make this more efficient, and also also depending on the market and how to evaluate this type of what type of brand it is and what type of market it is, for example. And access to data is very critical, that you really get the data and you can use it in a very various ways. And then, of course, different supporting tools can help to scale up the circularity. So what we have done with the supporting tool here, and also you will hear in the pilot, is one way of looking into it, but there will be needed with different types of technologies to move forward. So that is some of the key insights that we still work on. And now I hand over to Leah, I think.
So, yes, we will now start with with the pilots. And indeed, we are also happy that we're joined by Leah Bott from Texaid, the Senior Recycling Solution Specialist, and David Fusco, Project Engineer at STAM. And they will share their experiences implementing digital tools within textile sorting operations. So, Leah, you go first. Please go ahead.
Yeah, thank you very much for the introduction. I hope you can now all see the first slide with the picture of the sorting station.
Yes.
Okay, perfect. Yeah, so we are happy to present to you our sorting pilot from the CISUTAC project today. It's David and me who are presenting, but however, as you all know, it takes a whole team of people to perform the work. And so on the right-hand side, you can see all pilot partners and supporters that have been involved in this pilot. In the middle, you can see, or on the more left side of the screen, you can see the sorting station that we have built in our Texaid facility in Darmstadt in Germany. There we do the sorting or preparation for our online shop. This use case is quite similar to what we have done with the sorting station. However, there were some differences. So we try to compare as good as possible, but there were some limitations. In general, the idea behind this sorting station was to build a manual sorting station with sophisticated aids to sort for reuse, repair, and recycling. As you could see, there was a lot of previous work done in the CISUTAC project, and the sorting station was based on these outputs. So the decision support tool that Catherine already introduced, all the research on data points that are needed for sorting. And also there was the development of an AI model to detect, for example, color and also the gender, for example, of the product. And also this AI module was used for the sorting station, was integrated. On this slide, it's a little bit a different design than what Catherine just showed, but it's more or less the same data points. These are the data points that have been detected within the project that are required for sorting, especially when it comes to sorting for recycling. And this was the starting point for our pilot. So there were a lot of discussions going on about these data points. And within these discussions, we realized that there would probably be even more data points that we need to consider. So, for example, the size of a product will be very important if you want to sell it online. And so, as we were not only considering sorting for recycling, but also for reuse, we needed to consider a few more data points. And in general, our goal was, or in our discussions, our goal was to find a way to achieve as many of these data points as possible for our sorting station. And we were able, to work with these, I think, 14 data points in the end. So why were we only able to work with these data points and not with all of them? So the starting point is where do you get the information from? So we had, for example, the near scanner to give us information about the fiber composition. We have a manual sorter to give us information about the condition level of the garment. And we had the AI model, which was giving us information about the color, the gender, and the market price. But it makes a total of 5 data points, which is definitely not enough to channel a sorting decision. And it was definitely not enough to use our decision support tool, which we wanted to use. That's why we decided to create digital product passports for a certain set of garments, so we could use more information in our sorting pilot test station. So we were able to use more information. Now I would like to give you a brief overview of the workflow at the sorting station. You can read this chart from the left to the right side, starting with the operator taking a garment and spreading it on the table, and ending on the right side with 7 different sorting decisions. There we have reuse, repair, 4 different recycling options, and incineration. What you can also see is where the information for the software is coming from. So we have the DPP information carried with an RFID tag. We have a camera and the AI model to capture some data points, and the near scanner. And what you can also see is the green squares. This is each time when the manual operator needs to interact with the system. So he takes the garment, puts it on the table, he has to enter the condition level, and in the end, he has to take the garment and put it in a sorting bin. And now I would like to hand over to David, who will take you step by step through all the components of the sorting station.
Thank you, Leah. Oh, sorry. I think can you hear me? Hello?
Yes, we hear you.
Oh, okay.
Mm-hmm.
Do you still see the presentation?
Yes.
Okay, perfect. So my name is Davide. I'm a computer engineer, and my work was mainly in developing the interface and assembling all the work behind the curtains, basically. So we developed a system integration, basically, of all the software developed during the pilot. And I wanted to present a few slides that basically shows what happens in a technical level during our pilot, but I promise that I will be very, very short and quick. So the first step of our pilot was to use the RFID to scan the item, basically. So we mounted an RFID antenna and reader on the table, so that basically we had also an RFID tag inside the garment, so that when the garment is placed near the RFID antenna, basically a triggering happens in the interface. And basically what it happens is that this RFID tag embeds an EPC code, so a unique code that identifies the garment. And using this APC, we are able to extract the data that are stored basically in the GTS platform. The GTS platform is this platform that stores all the data of every garment that we had available during the pilot. So basically, the flow starts by scanning the garment, retrieving this EPC, and connecting this EPC to the data that we have in the database. We were able to retrieve most of the data of the garment. And after that, sorry for the music, we had an IR scanner that basically is used to detect the material of the garment. This was implemented in the pilot because not always we had the information about the fiber composition, so it was useful to have an hardware that detected the fiber composition again in case if it was missing. And then we had the last part of the data acquisition, that is the AI model. Basically, we used a camera to take a picture of the garment, and basically in the computer where the interface is running, there is an AI model that analyzes the images, and as Leah said before, gives back some outputs like the color, like the gender, and things like that. So basically what the operator needs to do is to spread the garment on the table, take the picture, and the AI model gives back the output. And then, as you already saw in the video, we had developed an interface with a touchscreen that should be, well, it should be, we developed it in a way that it was easy to use and simple, so that everyone is able to use it without having that much of teaching, of instructions. So basically the last step of the pilot after gathering all the digital data is basically assessing the condition and use the condition level that Catherine explained before to again state which is the condition of the garment. And as you see, when all the journey is complete, there is basically an indication of what is the best sorting result for the garment. And just to close about the technical details, as you saw before, this is the decision tree that we used, where is basically it is a file that embeds a list of constraints and rules in order to give a solution. So basically a reuse or repair, or as I can see these here, some idea of recycling. And we had to do some work because of course this is not totally usable directly from a computer, from a machine perspective. So what we did is to translate these rules into code so that we were able to develop the interface and use it automatically, let's say. So embed all the flow to give back a result automatically. And yes, I think I'm done. So I think I give back to Leah the word.
Yeah, so coming to the end of the presentation of our pilot, we want to summarize the key results and learnings that we had during this process. It's not really surprising, but more data enables more differentiation in sorting. As you could see, we had 7 different sorting options, and so we needed enough data points to really differentiate these sorting options from each other. And we've also found that sometimes it's only one little piece of information that might be missing, and then a textile will go to incineration instead of high-value recycling. And so, this is very crucial. In general, we saw that the interaction between all components worked, especially when we look in the interaction between software and hardware, and also the processing of all data through the decision tool. So we were really happy that we could make it work and got the station up and running in a very fast time. We found that the table had a high user friendliness because we had different people using the station, and only after a few minutes of showing how it works, everybody was able to use the station. There we also had one colleague from Texaid where we had no language in common, so we could only show her how to use the station, and even she was able to use it after a few minutes. So we think it could be a great benefit to have such automated or a sorting station with sophisticated tools, also to onboard unskilled persons very quickly. Then we could see that the sorting accuracy and complexity could be improved. With accuracy, we mean that the person will put the textile in the correct bin. And with complexity, we mean that we were able to differentiate in different recycling streams, for example, because a manual sorter without any tools would never be able to differentiate in so many different recycling options. When it comes to the digital product passport, of course, we see that it could be a great enabler for automating the sorting, but however, we still see restrictions as DPPs are not widely common at the moment. And even if they were, we see the risk that the information gets lost along the way. For example, if it's a QR code that is printed on a care label, the label can fade. People tend to cut out labels. Yeah, there we still see a lot of restrictions when it comes to DPPs. We saw limitations in the near scanner, especially when it comes to scanning black garments and also garments that are made out of a blend of more than 2 materials. Yeah. The assessment of the condition level is a bottleneck, not only because it took a lot of time in our pilot setup for the operator to enter the condition level, but also we need to have skilled workers that have the know-how to assess the condition level. And this is always difficult, and it takes people a long time to really learn how to assess the different condition levels. Then when it comes to our AI model, we unfortunately saw that it was performing with a low accuracy and low consistency. Nevertheless, we know that AI development is booming, and there's a lot of progress in this field. And we see huge potential in using AI to automate and digitalize the sorting process. And that's why we will use the remaining time and budget in this project to have a deeper look into this topic, how we can use AI for textile sorting. And in this process, we are also investigating existing solutions on the market. And yeah, so that's now I would like to hand over to the 2 companies or startups that will present their solutions in this field.
Yeah, thank you very much, Lia and David. And there are some questions in the chat. Maybe you can have a look at them when we start with our next presenter. So like Lia said, we moved to another pilot case, the Kringwinkel Antwerpen and the TroSort pilot. And we are very pleased to welcome Akhil Matot, co-founder and CEO of TroSort. Akhil, the floor is yours.
Thank you very much.
And I just also say hello. We are ahead of time, so please take your time for this presentation. I'm sure that many are very interested. Just wanted to say that. Thank you.
All right. Thank you very much. Hello, everyone. Really happy to be there and present what we are doing at TroSort. I'm going to share my screen, prepared a few slides. Can you see my screen?
Yes.
Perfect. So at TroSort, we are on a mission to upgrade current textile sorting processes with the long-term vision to be able to avoid sending textiles to landfills by treating accordingly the cloth ahead in the value chain. So we are a small team of 6 mainly engineers. We focus mainly on software development, but we also develop hardware systems. I'm going to speak a bit more about that. On the side of the software, we have developed our own algorithms and use existing algorithms to detect characteristics of clothing from images, just like a bit CISUTAC has been doing. And we try to go a bit further by also trying to automate the detection of the condition, so the grading of the items, by detecting the different types of defects on the garments. And on the side of hardware, we try to have an efficient system so that we can reach near complete automation or semi-automation for operating the sorting. I just took a screenshot of the data points because I think it's relevant and it's easy to see where we place ourselves at TrustSort into that value detection. So at TrustSort, we really focus on everything that's related to resale, also repair, a bit less on recycling. So we have tried to develop tools that could be profitable from day one for textile sorting centers. So that's, I think, we normally tended towards reuse. So starting from the reuse part instead of recycling part, since the state of the market. And so we are trying to get all the different data points that I have highlighted in blue, and also as CISUTAC discussed, it's also important to get other data points such as the size. I saw also the seasonality. I'm going to speak a bit more about that later on. So we started in 2024, in July 2024, and we built a first prototype that we installed at Kringwinkel Antwerpen, and that they were able to test. So the goal was to automate picture taking from both sides of the garments, extract the different data points using computer vision models, large language models and other, and then to automatically route the items. Of course, this was the first prototype. We got a lot of feedback. It's not fast enough. We don't use hanger logistics, and we don't want to use hanger logistics. Pictures are not great enough, etc., etc. So we went on. Yeah, that's a bit the results that we were able to obtain. At that point, we were already able to get an 80% accuracy in brand detection. So we were confident that continuing on that route would be interesting. And so we arrived today with the system that we have after a few iterations and a few European projects that we have done. So today our solution is called SortMate, and so it's an AI-based textile sorting for resale, repair, upcycling, and looking forward ahead, recycling. So what we do is we automate 360-degree garment pictures at a high throughput. So as you can see, we are able to retrieve picture from the front face and from the back face of the garments automatically while they are laid on a conveyor belt. We then analyze these images to extract the different characteristics of the piece, so the type of the product, the brand, the colors, the size, the composition of materials, thanks to a near scanner into the system. And we also have a pricing engine that is trained on online marketplaces transactions, so that we are able to provide a potential resale price for a piece that is based on European data only. And then our software enables to compute automatically a sorting outcome. But at the difference from CISUTAC, we have not tried to make a standardized version that we would provide to the sorting center, but more allow the sorting center to decide the exact criteria and condition that they would like to sort with. So yeah, less of a view of standardization and dissemination, but more a view on really just product specification from clients. So they are able to enter the different conditions that they want for every item, and that gives a result. The result is a bale number, and we have developed a system to automatically route the items to the right categories. I think that's a well-known technology using air, compressed air. I have a video afterwards, but so to give you the showroom configuration that we installed at Kringwinkel Antwerpen. We have first a conveyor, sorting conveyor, the different bales that are used to blow the items in. the blowers, as we call them, the little devices that will push compressed air on the pieces so that they arrive into the bales, and the scanner part, as we call it. So it's a conveyor belt with a multiple camera system and an ear system integrated. So how does it look like? So that's how it renders. So there is a need for an operator to lay down the garments on the conveyor belt. The first thing that is detected is the material composition thanks to an ear scanner, and then the pieces, they go into the scanning box, let's call it, so that we take picture from top and from bottom. We extract the different characteristics of the piece, and based on the characteristics that have been detected, the items are blown into the category directly. This process digitizes the piece. It also prices them. We also get picture from them. So we also analyze the possibility to make online resale with it directly from the line. What we saw is that to sort efficiently, an operator is able to lay down a garment every 6 seconds on the conveyor belt. But when you want to make pack shots, you need to take more your time to put the cloth correctly on the conveyor so that the pack shot looks quite correct. So it takes more around 15 seconds per piece, but it enables to do online resale. And so that's what Kringwinkel has been doing with our system in production since, I think, end of January. So I invite you to visit their website, Kringwinkel Antwerpen shop. And you can see that we push automatically the different informations of the garments that they pass through onto their Odoo shop. So basically we have a stock management system. You can see everything that's gone through the machine. You can adjust the different data points if there are errors or misclassifications, change the price, and then publish everything on their web shop within a click of a button. And in terms of pack shots, we've done quite some work on getting the cameras right and the automatic post-processing right. So that's the picture that we get raw from our system. And this is automatic post-processing that we are able to do. So it's basically removing the background, adding a bit of a shadow around the piece. And the system can also accept garment with hangers or without hangers. That was a requirement to be able to process multiple logistics. I have a few examples of pack shots. And we also made a project with CRG, so Class Retail Group, which is a retail company in Belgium, to make pack shots that are industry grade using models that are available on their website. So they sell kids clothing. So this is a model that comes from their website. This is raw pack shot from our system. We have an intermediary step to post-process the garments, and then we are able to swap the pieces on the mannequin. Of course, this is only a demo version. This is not in production. We have seen that the tools are getting quite good to automate such product swapping or even complete model generation. They are getting more precise in keeping all the characteristics of the garment without, let's say, over modifying the piece to make it look beautiful. And so we believe this is a trend that will continue to go on in the industry, and that pack shots will be able to be automated at scale for different products. That's a take that Trossard makes, at least. That will be able to arrive at that point for production readiness quite soon. And so that's a bit what we're doing at Trossard. Happy to share more if you have some questions. Thank you very much for listening.
Yeah. Thank you, Akil. A very concrete illustration of how data-driven sorting can work in practice. There are some questions, maybe in the chat. Maybe we can have a look at that. And then in the meantime, we will move to Atelier Reforma for the last pilot. So, Elena, the floor is yours, and welcome, of course.
Hello, thank you very much for inviting me. I am sharing my screen. Tell me when you see it. Can you see it?
Yes, we can see it.
Okay, so good
Yes.
morning. I am Elena Ferrero, co-founder and CEO of Atelier Riforma. We are a startup based in Italy whose mission is to help the fashion industry to be more circular. And along with the many services we offer, we also developed and patented a technology called Refor Circular that is quite similar to the tools you have seen from CISUTAC Consortium and from Trozort. So it consists of a classification technology supported by AI that is capable of automatically identifying and recording all the characteristics of a garment, useful for channeling it towards circular economy processes. For example, type, seasonality, color, gender, size, if it is from a luxury brand or not, weight, composition, pattern, etc. You just need 2 photos, one of the garment laid flat on one and one of its label, if it's still present, of course. No need for bulky equipment because our web app can be used on any device with a camera, which is fixed on a stand, similar to that of CISUTAC, so that it always takes photographs at the same distance from the clothes. Together with the Refor Circular, we also supply a portable near spectroscopy reader to identify the composition of textiles when the label is no longer present. And there is only one parameter that remains within human competence, that is the condition of the garment. And this is determined by the operator, who then proceeds quickly and easily to select one of these 3 options from the cataloging dashboard: flawless, slightly damaged, or very worn. In fact, given the extreme variety and randomness of post-consumer clothing, it is difficult, in our experience, for AI to determine with accuracy, for example, whether a tear is the result of the wear or an intentional element of the garment's design. And the same applies to stains or to the thinness of the fabric. So is this intentional or the result of wear? So we decided not to focus on developing an AI algorithm to identify the condition of garments because we consider that the error rate would be quite high, and consequently also the frequency of corrections required by the operator, and this would only slow down the process. So finally, each item is also automatically assigned a price based on all the parameters I mentioned before. In fact, linked to this textile sorting and digitalization technology, there is a marketplace platform which brings together the B2B supply and demand sides for these materials. So Refor Circular allows 2 operations to be carried out at once, saving time: sorting, but at the same time putting items up for sale online automatically. So in our vision, it is not Refor Circular that sorts the destination of the garment upstream, although it could easily do so, but the market that does so. So once the garments are on sale on the marketplace, those most interesting for resale will be easily found and bought by second-hand shops. Those most interesting for upcycling will be purchased by upcyclers. Those suitable for recycling will be bought by recycling companies, and so on. These careful choices can be made thanks to all this data, which is transmitted via the platform through the platform from those who have textiles to those who are seeking them for their business. And this is a transparent trade for both parties, which is difficult to achieve in normal offline wholesale commerce. So we designed the Refor Circular as a lightweight technology, easily installed anywhere and by any organization. There are no adoption costs, so low risk for users and 0 barriers to entry, because our business model is based on a fee for each sale completed by users on our marketplace. In this way, Refor Circular can be used by profit and no-profit organizations, large and small, that collect or select used clothing, but also by companies and entities that have their own textiles that they would like to valorize in the circular fashion market. So we think that carefully sorting post-consumer textiles is not useful if they cannot then be... Yes? Sorry? Oh, okay, yeah, Matt. So I repeat, we think that sorting post-consumer textiles is not so useful if they cannot then be valorized in the circular economy market. So it is on this principle that we have based our tool, which we hope will be useful, a driver in making textile management more circular and transparent. Thank you.
Thank you very much, Lena, for sharing your experiences. Yeah, we have now come to the panel discussion, and we bring all speakers back for this discussion. And Emma will moderate this panel discussion. So are you ready for it, Emma?
I am ready.
I see it. Great.
Okay, great. Thank you for a very interesting pilot presentation. I am so thrilled that we have a solution, commercial developed solution, but also within our EU projects community, different kinds of solutions underway. Things are actually starting to happen in this field, so that's very, I think, exciting. But I think I will start with a question on data quality, because now we've heard a couple of solutions, and where are we? Where are still the biggest challenges that you foresee with scaling this use of data in different digital solutions? Is it technical? Is it standardization? Is it the interoperability? Is it availability? Is it the readiness of the reuse or recycling companies? Where are we right now? What would you say? We can perhaps start with Trousseau that are working with the Kringvinkel as an example.
Sure. I think the two challenges will be about availability and interoperability, as you said. The first one, because we need to create data sets that are of high quality. For example, we try to train models from the CISUTAC project picture. So I think there is a set of 36,000 images, something like this, that are qualified. The thing is, for example, for us, the resolution of the picture was not high enough to be able to detect correctly defects. So that's why we needed to start again and find ways to annotate the data ourselves quickly. So that's, I think, one of the biggest goals is to being able to annotate at a high throughput qualitative data using garment pictures. So availability and interoperability, what we saw is the difficulty in getting a feedback loop to train a model from field data points. So what I mean is the characteristic that we detect from the pieces, we generate different data points, and then our clients, they use other data points. So we need to make a mapping from what we detect to their own wording, let's say. But then when we want to, so if they annotate, they make changes, or we get sales data from their POS system, for example, it's complicated to come back to a feedback loop so that we train again our models from the data that we receive, because it has been trained on other data points. So we need to have this mapping for each customer, and it gets quite complicated at scale. So that's something that we haven't cracked yet, but we are looking to do it. And I think that's one of the main challenges.
Very interesting. Let's hear from the others. Should we go to Atelier Reforma? How do you see the biggest challenges when it comes to data quality?
Yes, I linked this question to the DPPP because the challenge I foresee is that a lot of data is transmitted, but this data maybe isn't so useful for an effective end-of-life management of products. Let me explain. Of course, it is very useful for the consumer to know whether a garment was produced respecting workers' rights through the DPP, but maybe this information isn't useful for determining whether the garment can be sold on the second-hand market or recycled. It's fine for the DPP to provide information on how to return the garment to the brand in question for repair. But if that garment ended up in the collection bins and I'm now sorting it, that information is not useful to me. So this, I think, is one of the challenges.
Thank you. And now we have 3 CISUTAC representatives, so you have to see. Perhaps you can answer it from different perspective, a little bit from a sorting perspective, technical or research perspective. But what do you see like the biggest challenges when it comes to data quality and scaling?
I would like to add maybe one point that has not been mentioned yet. It's about data semantics. That was one big challenge that we found within our sorting pilot, that maybe the information is there, but the information also needs to be aligned between different systems and different stakeholders. For example, the size, some can say it's a size 40, some will say it's the M, some will say the color is red, some will say it's raspberry. And so there's a lot of semantic topics where we need translation, alignment, and so on. So I think this is as well a big challenge. And when it comes to sorting, I mean, we are at the end of this whole process. We have to deal with what we have. And at the moment, state of the art in sorting is manual sorting. So we get all the information that the sorter will see and feel. And any additional information will be helpful. We will see what will come in the next years.
Any other comments from David or Catherine on this topic?
I just want to add that maybe from a pure technical point of view, one problem that we had was not only semantic, but also the standardization of the data, because basically how we went is that there was the development of the decision tool. And once we had the decision tool, we saw that some points were more relevant than others, but then we had to face the fact that we were not able to have all the data available. So we needed to put some restriction and limitation to what we were able to do, because there was no alignment from the industry, what the industry want and what the producer are able to give. So also this standardization thing is a problem that we had to manage somehow.
Thank you so much. Okay, we will get back, I think, to the question also on how we go from pilot to scaling a little bit further on in our discussion. But I would first like to discuss a little bit about how you go from the technical solution with all its challenges to building a business model that can thrive and help the developers of the technical solutions as well to further then continue with the development of the solution, so to speak. And it was very interesting that here we can see you have already different thoughts of the business model. Atelier Reforma, if I understood correctly, you have also included that different stakeholders can adopt technology, because that is also important, of course, that you can afford it and try it and understand it. And interesting for you, Trousseau, that you have worked with also a charity organization as the Kringwinkel. So also for small and big scale and so on, organizations to try this technology. And when it comes to CISUTAC, we have not only focused on the reuse business model, but also try to explore what will this mean for a big scale sorter that also have the big volumes that also needs to sort for recycling. So perhaps from your different perspectives, what are your thoughts about business model for these kind of solution? Where do you start? Where do you need to like find the strength and the upside to not basically go bankrupt and continue with your solutions? Because that is a question right now where we are in the market. So perhaps we can start with Texaid from your perspective as a sorter. Where do you stand?
Yeah, well, I think our perspective is quite clear. Our business case is reuse, selling garments for reuse. And I think that's also probably the starting point for the presented solutions, what I could see from the presentations. And unfortunately, recycling is not a use case yet. I mean, recycling is not scaled. There's no take up of any volumes. So from our point of view, yes, in the future, we definitely are interested to be the supplier of feedstock for textile to textile recycling, but this is just not existing today.
And thoughts from Atelier Reforma or Trousseau?
Yes, if we think at these digital tools, so sorting digital tools, I think the best business case is for organizations that are also open to selling textiles online, because digital channels are essential for transmitting data. If I collect and record data effectively with these tools, but it then remains in my database, what impact does that have on my business? So not much. If, however, I can use that data immediately to sell my materials and increase my profits, then the data will be really useful to me, and so I can exploit it better.
And from Achille and Trousseau, what are your thoughts?
On our side, on the business model, at first we started as a per item scan cost based business model. Then we saw that it was not really fitting the needs of the sorting centers. They kind of started to have thoughts of, okay, then I will try to pass as less items as I can in the system to have less costs. But what we want to enable is indeed to test it in every way possible so that you find the most efficient sorting system that you can have, depending on the multiple step sorting that you have: first sorting, second sorting, third sorting for recycling. Some only have first sorting, some have the three, some have more. And so we wanted to provide just a per month cost for both the hardware, the software license, and the maintenance of the equipment. Also the upgrade of the software over time. Because it's still in development, but it's already ready for the market for a few use cases to be profitable. So that's what we're already doing. And we wanted to limit the capex investment at first for the sorting center, so that we could come with something that you pay per month with nearly zero capex of entry, and it starts being profitable from day one. That's what we're trying to do. So right now we have sold 4 systems in Australia, in the UK, in the Netherlands, and in Belgium. Under that business model, it seems to work. Our goal is to extend and be able to provide a smaller price with the time by optimizing hardware costs and everything. But I think it's the way that we chose to work on.
Interesting. And are the companies and sorting and reuse organizations screaming for the solution, or do they need more knowledge that the solution is out there, or how's the demand of these kind of solutions in the market?
I continue on?
Yes, please.
So I think there is still a lot of skepticism, which is legit, because AI is relevant but not always accurate. So our goal is to make sure that we arrive to industrial readiness on accuracy points, and that we can convince people that it works perfectly. So we have held a showroom at Kringwinkel Antwerp's place. At first, it was hard to make people come, and now we have all the sorting centers over the world that are coming to see the system. Also, very large brands and retailers that have large-scale second-hand or take-back programs. So I think in the coming, I think 2026 is the year for looking at AI automation in textile sorting and resale. And yeah, this will be the years of the use cases that will come out. There is still a need to get those use cases in a very scientific way, well documented, with very transparent, I think, return on investment computations to share with everybody, so that transparency brings trust and we can go forward all together in the market. So that's what we will do this year.
Interesting. Thank you so much. Let's go over a little bit to the topic of condition and grading condition that CISUTAC has identified as really important and has a draft of a standardized grading system. And here you have done a little bit differently. As I understand, Elena, at Atelier Reforma, you have not, so to speak, gone into that question yet, and you have tried with AI at Trousseau, and actually CISUTAC will do a work around this with AI during the spring, so this is interesting. So perhaps we should start here with CISUTAC, a little bit on how do we tackle this, doing the condition grading with the digitalized tools. What are the CISUTAC thoughts on that? Would you like to comment that, David?
Sorry, I was answering a question in the comment. Could you please repeat?
Dangerous, then you get not
Sorry.
focused. Would you like to
Yeah,
think
please.
a little bit?
No,
Or
could you repeat the question?
How we have identified condition grading as very important to scale, and also that it's difficult to do with digitalization and AI, but it's a potential. And we will do a work around this in spring. So what are your thoughts on the potential with AI for doing a grading on condition?
No, basically, what AI is good for is actually to from an image trying to detect a set of characteristics, and in this field AI is improved a lot since the starting of the project. And sorry, there is someone is not muted.
Someone needs to mute. Thank you.
So
Okay, go ahead.
Okay, thank you. And my thoughts on that is that AI again is had achieved a lot of improvement in by the time that we run the project and the pilot. So it will be really useful in identifying which are the characteristics of an image that the AI is analyzing. But I also think that strong work from experts in the field it's still needed to actually define what is a condition, and to exactly to do an exact mapping between the characteristics of a garment and the condition. So the AI will be really useful in automatically acquiring the data, but then we still need a strong work in research to map between this data and the condition.
Any other comments on this topic from Trousseau or Atelier Reforma? How do we tackle the AI challenge with condition further as an industry?
So I think there is the potential to develop this, because AI is developing quicker than we think. So when we started, we thought that it wasn't able to do that. It wasn't able to substitute the switch from human competence to artificial intelligence, but it could be possible. The challenge for me is the error rate. So if the operator then have to correct really frequently the output of the artificial intelligence, this doesn't speed up the process anymore. So it doesn't is worth the effort to do that. It is for this reason that at the moment we have decided to leave that parameter with a manual entering of the data. So really also that is designed really to be really quick and easy to do. So you just press a button, select an option from 3 options. You at CISUTAC have maybe 4 or 5 I've seen, but it is at the same time really, really quick. And I think it doesn't slow down too much the process overall.
Thank you. Any comments from you?
Yeah, on our side. So we've taken the challenge to automate it. Indeed, we need a lot of data and comparison points to be able to achieve great accuracy. But the results are very impressive. And there are still limitations in terms of the system to be able to view, for example, inside the garments. We've had a sorting center that told us if I cannot see stains inside of a pants, for me, I won't use it. It was only one on the 30 plus sorting centers that came to visit the showroom, but it's still some requirements that are missing also for high grade garments, for luxury items. We saw a lot of different requirements from high-end brands that are very different from the requirement from a sorting center. And yeah, I believe that we can achieve like mid-market automation for defect detection. But when it comes to €100 plus items, then I think a manual check will be needed. And yeah, we also foresee in the future complete automation of the sorting process with automatic feeding. I think if you've already seen the Valvon fiber sort with the automatic picker, that's something that you can imagine in the future will also come for sorting a complete process, also for reuse, even if there is still a human in the loop. So we took on that challenge, and we think that's the way to go. But for the time, with accuracy lacks, what we decided to go for is to include a microphone into our system so that we can have a voice-based input from the sorter if necessary, in order to keep his hands free and try to still have great throughput while doing so. And the voice of the sorter oversteps the vision detection-based models currently. So that's how we try to implement it, get more data, get annotation automatically. So basically giving a profitable system while also continuing on improving.
Interesting. Thank you. Perhaps we should start to wrap up, and I would like to ask you a last question about how do we go from scaling to pilot, and perhaps give from your 3 different perspectives 3 aspects or factors that you need to go further in scaling the solution. What would you choose? A little bit short and sweet, so to speak. Should we start with CISUTAC, and perhaps if it is possible for David and Lea to answer that together, if you can coordinate 3 short and sweet?
I'm not sure if I can put it to 3. I think from our perspective, it's quite clear that, or at least that's how I see it. I see there's a lot of technology and possibilities available, but what's really missing is the security to invest and to have really planning security. So I think that we need very strong political commitment and good legislations that will support this process, this transformation process, and that will give us the security to really invest in these technologies and scale it up. Because I think the puzzle piece that's missing most at the moment is money, and that's my one and sweet.
Show us the money. Okay. David, from the technical perspective, do you have something to add?
No, again, basically it's just that we need to be aware of what are the technological advances that happens while we are developing. So maybe we focus on one thing and then we saw that somehow in some way there is a new technology that completely disrupts what we have done. So my input is that we need to also have an eye on what are the overall researches that are being currently doing in the world, in this world.
Thank you. And from Atelier Reforma, what are your 3 short and sweet?
Really short, I think the biggest challenge is the mismatch between textile availability and the demand in the circular fashion market. So
Yeah.
I think that a main driver for the adoption of this technology and scaling will be the EPR system, which will give funds to the entities dealing with these processes.
Thank you. Great answer. And from Trousseau, a last word.
I think to scale, we need a very strong data architecture processing. As I said in the beginning, doing the training on specific grading criteria for each customers. It requires a smart way to gather data and to be able to train on each endpoint data back your complete system. And that's one. The second one is indeed having profitable use cases as fast as possible to spread the technology. And the third one will be, I think, more automation to be able to go even at larger scale in terms of volumes processed. Because today we are still at less than 20% of textile materials that are even collected. So if you want to go further, there will be need for even more automation.
Thank you. I will hand over to Lisbeth.
Yes. Well, thank you all for this lively discussion, and Emma for your good questions. We are approaching the end of our session, and I would like to sincerely thank, of course, Catherine, Leah, David, Akil, and Elena. And a special thanks to Emma for putting everything together and making this webinar possible. So thank you very much. We have seen today the digital product passport and digitalization in the textile sorting are not abstract future developments, but they are already shaping operational decisions today. And the pilots we heard today show that preparation is essential, that the data infrastructure matters, and collaboration is key. So we would like to thank all for joining us. And like we said before, we will share the recording and the slides with you afterwards. And we hope to see you next time. Thank you all very much and have a nice day.
Thank you very much.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Bye-bye.
Bye. Thank you.